Okay, we're going to do a walkthrough for one of the questions in this learning activity. So here on slide 3, we have a picture of a beach with a turtle, and he's trying to get up out of the water. And then we have a graph that shows the distance from the water the turtle is for any given time. And if we hit play, we can kind of see this play out here. So the turtle's walking away from the water. He stops, so his distance from the water stays the same. Then he starts to walk again, and then he stops and his distance from the water stays the same again for the last little bit there. So on this slide, they ask you some questions about the graph. So using the graph, what is the turtle's distance from the water at 8 seconds? So 8 seconds would be right here. And if we look at the graph, it would appear that the turtle is this far from the water. So let's see, it's going up 4, 8, 12. This is in between 8 and 12, so that would be 10 feet. So 10 feet from the water is how far the distance of the, So the turtle is 10 feet from the water after 8 seconds. Okay, then it asks, when is the turtle's distance from the water equal to 4 feet? So 4 feet would be right here. Okay, when does the turtle get that far? So if you look here, this is the point where that happens, and that appears to be 6 seconds in. Nope, sorry, 5 seconds in. Here's 4, here's 8. This would be 6, and then halfway between those would be 5. So 5 seconds in, the turtle is 4 feet away. 8 seconds in, the turtle is 10 feet away. Now, this question, we want to build some equations that will model this graph for us. And the first one's been done for us. You have y equals x, because this graph is just going up 1 and over 1, so the slope is 1 over 1. And you could even change that to 1 over 1 and see that it's still the same graph, right? The reason why I didn't have it there to begin with is because when you do 1 over 1, that just equals 1, and 1 times x is just x, so they just wrote it as x. Now this part right here, what this is doing, if I delete it, you'll see the graph is there for the entire time the turtle's walking on the beach. We don't want that. We only want the turtle to be going this fast until 2 seconds in, and then he stops, right? So we want to stop using this graph 2 seconds in and change it to this graph. So what we're going to do here is we're going to restrict where we're using this graph by using our curly brackets and writing in the domain of this graph. So it starts when x is 0 and goes till x equals 2, and it's everything in between. So the way we write that is we say x has to be bigger than 0. So x is bigger than 0. And see how that cut it off at 0? And now we want x to stop when it gets bigger than 2. So x has to be less than 2 for us to graph this. And when you combine those two facts together, that x is bigger than 0 and at the same time less than 2, it'll graph everything in between 0 and 2. Now these other 3 graphs we're going to get by doing 3 other equations. And to kind of help you out with that, so this one right here, its slope is 0. It's going up 0 and over however many you want to go. So the slope will be 0x. Okay, so the slope is 0, so I'm going to put 0 times x. And then notice that it draws this green line down here. Well, I don't want it there. I want it up here. So I can move it up there by adding 2. And what that does is it shifts the line up 2, makes it cross the y-axis at 2. That is the line I want for this equation, but I only want to use it between 2 and 4 seconds. So I'm going to restrict its domain. It's going to start at 2, and it's going to go until it reaches 4. Okay, so I chopped it off. So it starts at 2 and ends at 4. Okay, now this graph, this is the last one we'll do, and we'll let you finish the rest yourself. But this graph right here, its slope is going up 2 and over 1. Okay, so the rise is 2, the run is 1. So the slope would be 2 over 1. Okay, so I'm going to write that here, 2 over 1 times x. Okay, now notice that gave me the right line, or the right slope, but the line needs to be moved over to here. Okay, so what I'm going to do is I'm going to try and mimic this point right here. This point is 4, 2, over 4 to the right and 2 up. So that's the coordinates of the point. Don't get that confused with slope, which is how the line is changing as we go along. This is a point on the line that is 4 spaces over from the origin and 2 spaces up. It's a position. Okay, this is a rate of change. So this line, I want to move it up 2 spaces and over 4 spaces so that it's here instead of going through here. And I already know to move it up 2, I can just add 2 to this. Okay, see how that moved it up 2? Now I want to move it over 4. So the way I do that is I put parentheses around the x, and in here I do x minus 4. Okay, see how that bumped the line over 4 spaces? So that is now the graph that I want. Okay, so here are some other answers that people put for this question. Well, here's the one that we put right here. We're gonna look at some of these others and see how they're really the same line. They still work, they're just going about graphing it a different way. So first is this one right here, y equals 2 times x minus 4 plus 2. Well, why is that the same as y equals 2 over 1 times x minus 4 plus 2? Well, 2 over 1 is 2, so you can simplify your slope into a single number sometimes. So when you type your slope in, you don't always have to write the rise and the run you found. You could do maybe up 4 and over 2. Up 4 and over 2 gives me the same line that I do when I go up 2 and over 1. I could do up 6 and over 3. Okay, if I go up 6 spaces and over 3 spaces, that's still giving me the same line. And all of those, 6 divided by 3, 4 divided by 2, 2 divided by 1, they all equal 2. And so I could just put a 2 here. It's the same thing. Okay, that back. Now this one here, it's starting with my line of 2x, but then instead of moving it up 2 like we did, we just move it over 3. So that x minus 3 in the parentheses moved the line over 3 spaces directly instead of moving it up 2 and over 4 like we did to begin with. But you can see the results the same. Okay, we don't have to go up 2 and over 4. I could just go over 3 and I get the same line because now I'm starting here and going up 2 and over 1. Now we'll still have to cut it at this point, okay, but I can still get the line by saying it's a line with a slope of 2 shifted over to the right 3 spaces. Okay, now let's look at this last one. They put 2x minus 6. So if I type that in, okay, it gives me the same line. What that one's doing is it's moving the line down 6 spaces, and that's off my screen. You can't, oops, you can't really see it, but if you were to go down 6 spaces, okay, that would be where it crosses the y-axis. And you can go up 2 and over 1 and eventually get back to where we're at. So if you were to go back 1 and down 2, I guess, to say, you could find out that it ends up back at -6 on the y-axis. So these are all the same line, same equation, just different ways of writing it. We can shift it down 6, we can shift it right 3, we can shift it up 2 and right 4. We could even do something else. We could say go up 6, so shift it up 6 spaces, and then from there shift it over 6 spaces. 1, 2, 3, 4, 5, 6. Yeah, so it'll put it here, but it's still going to be the same line because it's a line with a slope of 2 over 1 that goes through this point. And just to show you, so we're going to move it over 6 by doing x minus 6, and then we're going to move it up 6 by plus 6, and there you go. There's your line. So it doesn't matter how you type the equation. You basically want to find a point on the line somewhere and use how far over and up it is to get these two numbers for the shifting. And then you want to figure out the slope of the line, whatever the ratio between the change in y and the change in x is, and put that in for your slope. Okay, now once that's all said and done, now we still have to restrict a line between here and here like we've been doing, but we'll let you figure that out. What does x have to be between for this to be chopped accordingly? And then we'll let you do this last little equation here to figure out how to finish the model. If you have any questions, let me know. Be happy to help you out. Hope this video helped.